So this I just want to quickly touch on as well. Um, this is not very too overly important. This is just a intuitive formula here. You can see they say in the in the case where you have function of x, y, and z, the normal the tangent plane. Okay, so the tangent plane is um, is of this formula here, and that kind of makes intuitive sense, right? Basically, if you have a slope like this, and then so basically that's your gradient vector, right? And then you have x minus x0, y minus y0, z minus z0. So what does that give you? Basically, that gives you in the 3D space, that gives you a gradient vector in 3D space, right? Fx, Fy, Fz. So that would give you, if you know the gradient vector, then you know the, you know this, you know the tangent plane, right? Because if you know the slope, if you know the vector of the gradient, and you know the gradient vector is perpendicular to the tangent plane, then you know how this tangent plane is positioned, is slanted, right? So then if you know how the tangent plane is slanted, and you know one particular point on the tangent plane, then obviously you've got the whole plane. So that is an intuitive interpretation of this formula here. This being the equation of the tangent plane, and then the normal line to the tangent plane, it just is just simply the gradient. So that's all you need to know. And for any question, let's say the next question here, if we take a look at it, find the equation of the tangent line. Find the equation of the tangent line and normal line at this point, right? So basically, you already know a point, and you want to find the gradient. See here, right here, that's the gradient vector. That's the gradient vector pointing out. So you basically just take your partial derivatives, evaluate your partial derivatives, and then that's your fx, that's your fy, that's your fz, and then this is your x minus x0, x minus, or rather y minus y0, z minus z0. Plug and play, and then you've got this 3D space, 3D shape, which is a plane here. Okay. So then same as for a 2D case, right? Let's say if this example was find the equation of the tangent line and the normal line at the point 2, 1 to the, let's say this would be like some kind of a, let's say, cone of this, right? Actually, this is not a cone. This is kind of like an oval shape. So let's say I'm changing the example by removing one dimension, right? So now you have x and y, and you have this, and then instead of dealing with tangent plane, we're dealing with tangent line. Okay, so then that would just be that. This disappears, right? We have fx and fy, and then we have this equal to 0. So then basically what we would have would be, which simplifies to, let's say, so we would have like just like part of it gone, right? We would just have like x and y, so that would be a line. Okay, so then you would have, that's the tangent line that you just found, and then the line, the gradient line that's perpendicular to the tangent line would just be this -1, so that's a vector, -1, 2. Okay,